Hello, everyone, and welcome to today's live event, Unlocking the Full Potential of Laser Cutting and Metal Fabrication with On-Site Nitrogen Generation, hosted by Purity Gas's very own Brett Rogers. We are so glad that you could join us today as we explore on-site nitrogen generation and how it can transform your efficiency and performance in laser cutting and metal fabrication. A quick note before we will begin, the session will be recorded and you can submit your questions anytime in the Q&A section, and Brett will be happy to answer them during the Q&A section at the end of the live event. So now let's get started, and I'm pleased and proud to introduce Mr. Brett Rogers. The floor is yours.
Thanks, Victoria. And good afternoon, everybody, or good morning if you're calling in from the West. As she mentioned, my name is Brett Rogers. I'm a sales manager here at Purity Gas. Purity Gas has been engineering and integrating nitrogen generation systems for several years, and we've watched our customer base and others struggle with their nitrogen procurement. And so today, what we're going to talk about specific to the laser cutting arena is unlocking the full potential of your operation through the use of on-site nitrogen generation technology. Now, everything that we're going to talk about today is going to lead to a better, clearer understanding of the technology, how to maximize its potential for your operation, and the topics we're going to cover are why on-site nitrogen generation is taking over as the preference and not the exception. We're going to drill down into those benefits, talk about what the critical parameters are, specifically pressure, purity, and flow. Talk about what system options are out there, sizing or matching those systems to your specific needs. Talk about the costs and actually the savings and ROI of this technology. And as Victoria mentioned at the end, there's going to be an opportunity for some Q&A. Yeah, by the end of this webinar, you're going to be well equipped to ensure that you know the right system for your operation, both from an economic and a performance perspective, and have that clear understanding of how to unlock the full potential of your operation with this technology. Now, a couple quick points about Purity Gas, who we are, what makes us qualified to present this type of information, this webinar. First, our origin. Nitrogen generation serves the purpose of allowing users to reliably and safely produce their own nitrogen. Most importantly, it provides users with a far more affordable option than the typical delivered nitrogen options. And Purity Gas was born as a result of seeing the nitrogen generation market being underserved, primarily by dealers and definitely not by experts. And the market needed leadership in this regard, and hence Purity Gas was born. The entire team here are nitrogen generation experts across all departments. And a little internal motto that we live by here is nitrogen generation is all we do, so we better be the best at it. Now, talking about our mission and our vision as a company, and there is an expectation that eventually every industrial gaseous nitrogen user is going to be using on-site nitrogen generation technology. And our goal is to educate first and ensure a seamless transition for anyone looking to benefit from the technology. And hopefully you learn enough from us that you choose us as your partner. Now, our demonstrated commitment to this industry, we have hundreds of nitrogen generators installed across North America, and that number obviously is constantly and very quickly growing. We have a pretty significant market focus on the laser cutting space. We've got several laser cutting experts on our team focused on this vertical, both from a customer experience perspective as well as R&D and engineering as well. So the shift, it's underway, and the eventual shift is inevitable. So we're going to look at why this is happening, and we've got three portions of the equation. And the first, the changes that we're seeing in the traditional delivery method of nitrogen, and that is the cost is increasing. It's getting more expensive every year. The degree of reliability is decreasing, or as I put, increasingly unreliable in this. And we're also seeing these contract lengths really start to expand 5, 7, even 10-year lengths. So we've got the one side with the traditional delivery benefits or improvements to the on-site nitrogen generation, both in its, or not both, but in its availability, the efficiency, and the affordability of these. So more and more of this is coming available. More and more of this is getting is more viable in different and more operations. Factor in now your specific business and the changes in metal fabrication. You've got, I mean, everybody's running fiber lasers now. You've got more materials that are using nitrogen and using more of it. You've got, 12, 24, 30. I think there's even 60 kilowatt lasers out there now, and the nitrogen usage is obviously increasing as a result. All of that leading to that shift in to on-site nitrogen generation, as I mentioned. Now, when we talk about the benefits of on-site nitrogen generation, we break them into four pillars of value, we call them, and they are expense reduction, operational improvements, environmental impact, and an occupational health and safety benefit as well. The one we talk about all the time is the expense reduction, and that you're going to see a lower cost per CCF or per cubic meter for our Canadian friends. You're not going to have the rental and the delivery fees. You're only going to pay for what you use. You're not going to have any evaporating to the atmosphere that you're paying for and then not using. Or consequently, or conversely, if you're buying it in cylinders, you have to return a certain portion of that nitrogen. So you're actually going to pay for what you use in this case. And then we also get to reduce the cost implication by narrowing in on what your actual purity levels are needed and designing around that, thus reducing the cost of the system and operation. And we'll talk more about purity in a moment. Second, operational improvements. And the last point on the first column there applies to both. So I'll talk about it here is there's no long-term restrictive contracts. We hear a lot of our customers, and I'd hesitate to say all of them, but we'll say a very, very high majority of them are really they despise their contract situation. They're not pleased. They're stuck in these contracts. They're not protected on price. It's just they're stuck in those and very hard to get out of. So you don't have to deal with that with on-site generation. You're also not going to miss deliveries. You could miss deliveries due to weather events, telemetry malfunctions, being put on a force majeure or put on allocation. Those are all what's going to lead to you not having the nitrogen as you need it. And of course, that goes away if you're not getting it delivered. From a sustainability standpoint, we're going to use less energy per unit of nitrogen than the traditional fractional distillation method. That's one part of the equation. The other is we're going to take those high carbon emitting vehicles off the road that are delivering. So, and again, you're not going to generate what gets evaporated to atmosphere. So, and then the last is an occupational health and safety perspective. You're not going to be handling that minus 320 degree nitrogen that can cause freezing or skin damage and burns or whatever you want to call it. You're not going to be moving around heavy dewars that you could spill. Heavy cylinders, you don't have to move those around. And in a metal fabrication shop, you're not going to take those bulk packs driving around your plant from the loading dock to the laser in what are typically pretty congested areas. Now, as far as some case studies, I wanted to share a couple of case studies kind of from the two ends of the spectrum from laser cutting operation. Now, this particular company, they were a large operator, they still are a large operation. They had ended up getting a multi-bank system, 6 of our largest generators. They did that entire transition from liquid nitrogen. They actually saved 69% on their annual nitrogen spend, turned into a 3.4-year payback, and they saved about 20 tons of CO2 emissions. Now, on the other end of the spectrum, this is a smaller laser shop who actually, when we first started talking to them, they said, I don't use enough. And they just did, I don't remember, well, it's here, they were using a couple of bulk packs a week. And through our free assessment process, we actually determined that they were using that 2 bulk packs. But given the cost that they're spending, they were actually able to pay back a system in 2.8 years. So they were recognizing the savings, but they also became a whole lot more efficient by not having to swap out their bulk packs, manage all their deliveries, moving the bulk packs through the shop as well. So the question that's often asked, not necessarily, in every chance or in every conversation that we have, but very often is when's the right time to actually make that switch? And we can identify several of those. First, when you run out of nitrogen, you miss deliveries, you're put on allocation or force majeure. Lasers are incredibly expensive, and therefore they have a very expensive downtime cost. So charging out hundreds of dollars per hour, not very beneficial to not be able to run your laser because your assist gas isn't available. When you run out of space, maybe you've got too many bulk packs on the floor. Keeping several of those on hand at any given time, that's valuable real estate and can also, pose a health and safety issue. When and if you want to positively impact the environment, as I mentioned before, increase the sustainability by way of eliminating the high CO2 emitting diesel tankers from that delivery process. Um, when your contract is up or before you sign a contract, the ROI and payback are almost always shorter than the contract lengths being offered. We're seeing, 5, 7, and 10+ year contracts becoming the norm. And what's kind of interesting is when we look at these paybacks of 2.8 years or 3 years, the strategy that many of my customers employ is, well, as long as it's shorter than the contract length that I have to sign up for. And that's a really interesting perspective and a good one. When you use enough, well, how much is enough? Our customers, they've made great use of nitrogen generation systems with incredible paybacks, using as little as a bulk pack every couple of weeks. And of course, it scales. The more you use, the more you save. When you realize you're spending more than you should or could be, you're all experiencing regular price increases in spite of contracts even, and some often upwards of 10% over a single year. And with on-site nitrogen generation, we're typically seeing between about a 70 and a 90% reduction in nitrogen costs. So if you Sorry, yes, I'm showing this slide. So if you don't, actually clearly understand your needs, you run one of two risks here, and that is speccing a system that's oversized, costs you more than it needs to from an initial cost, space, and efficiency perspective, or conversely, you get a system that's undersized, and that results in you not having enough nitrogen to satisfy what you need for your operation. And so what are the requirements specific to the operation? We have several, but we're going to start with the big three. The big three, there are three main parameters when we're sizing a system. We talked about those, or we highlighted what they were, but a little bit more detail. First, it's pressure, and more specifically, what the nitrogen outlet pressure your laser specifically requires. And this is typically set by the laser or the laser manufacturer. And in laser cutting, we see between 250 and 450 psi is the norm. With nitrogen generation, you have an opportunity to optimize your system by understanding that intimately, and so far as not oversizing over pressurizing a system unnecessarily. And that can allow for the use of smaller and less expensive components and less energy consumption as well. Pressure is not a one-size-fits-all specification, although in many cases it's portrayed that way. Knowing what your pressure is, what your actual pressure requirement is going to be beneficial to your operation. Next is purity, and this is a source of quite a bit of confusion regularly. And what purity means is actually the measure of allowable oxygen. It's not a measure of how clean the nitrogen is. Nitrogen generation is capable of producing nitrogen as clean, and in some cases cleaner than bulk delivered nitrogen. As far as your lasers need, oftentimes the laser manufacturer is going to spec that 5 nines, the 99.999% nitrogen. However, that spec's typically designed to, quote, cover their butts and not necessarily a true reflection of what the needs are. As far as what the needs are, it's based on the materials you're cutting. The market has experienced success with these established purities, and we run, minimum 95% for cutting aluminum, 99.5% for mild steel, and stainless, the most prone to oxidation, is 99.95%. Now, nitrogen generation is more than capable of producing the 5 nines, and we do it for other industries and verticals. However, it results in a larger than necessary and subsequently more costly system, both from a capital and an operational cost perspective. So, concluding that, understanding the correct purity, that's going to produce suitable cuts is critical so that you can challenge the spec and know what your true requirements are. Now, finally, flow. Flow is dictated by the material, the thickness of the cut, the thickness that you cut, coupled with the nozzle size that you're using and the pressure that's specified by the laser manufacturer. And knowing what you cut, what material, and what thickness is going to ensure the optimal system design. I say that because you might have a peak flow associated with 1 inch aluminum, but if all you ever cut is 1/4 inch, then there's no point in designing such a large, robust system for the 1 inch. Flows measured, how many cubic feet per hour of nitrogen you're going to be used. And one thing that we caution people with is do not get caught in your average usage, be it daily or annual, because that doesn't tell the story of at the hourly level. So peak usage is typically what we consider the critical specification to understand, except for some high pressure storage solutions, which I'm going to talk about later. But generally speaking, the peak hourly usage is what you're going to want to find out. You're going to want to have a look at the laser manufacturer's documentation, and that'll determine the actual flow rates required. And I've built something that looks like a typical gas consumption chart on the right side here. Now, sometimes those aren't available. You can employ a nitrogen audit, which we can certainly help you with, but you can also count on a reputable partner like us to have a library of these gas consumption charts at our disposal, and we do keep a library of them. So. We talked about the big three. Well, there's a fourth, and the fourth is specific to laser cutting. Laser cutting operations are different than the rest of gaseous nitrogen use cases, and that is, with the fourth dimension or the fourth parameter, and that is your hours of operation. Again, specific to laser cutting, or yeah, for all intents and purposes, specific to laser cutting, identifying what your hours of operation are, and that's going to help us to determine the right design philosophy for your operation. And that's the high pressure storage solution or mid pressure on demand. And again, we'll talk about those in just a moment. So now understanding the technology best suited for your requirements. Parameters are clear. Now you can use that information with, of course, some other inputs to determine which nitrogen generation technology is right for you. So first, we have selective permeation, or membrane technology is what is commonly referred to as. Now, membrane generation has a lower purity threshold. So looking back at our purity requirements, you may be limited on some of the materials that you can cut. Membrane does, though, come with a lower capital and maintenance cost, but consequently, you do lose something in efficiency, which you're ultimately going to require a larger amount of feed air, aka compressor size, and therefore more electricity used as a result of that increased air requirement. But it can serve a purpose. So should your specific operation tolerate the lower impurities, then it might be a fit. And typically, membrane, when we're talking about that, more suitable for lower volume nitrogen users. The other technology is pressure swing adsorption technology, or PSA, and this is what has the top end purity requirements covered, particularly when talking about laser cutting. We can produce purities that are rivaling or even surpassing that of what delivered nitrogen is. Also, some other benefits that come in the box. There's an integrated oxygen analyzer. They employ fail safes. So should you have a purity critical application, it's always measuring that purity level. And should there be a problem, it'll manage that. And as they say, if there's an issue such as a dip in purity. Also talking lifespan, with proper maintenance, you can expect a much longer lifespan for PSA versus the membrane or the selective permeation technology. All this, these PSA systems, they do provide the lowest air to nitrogen ratio, meaning least amount of air required to produce the same amount of nitrogen. So subsequently, less energy, greater efficiency. Now, those are the two technologies. We've got the two design philosophies that I've touched on a couple of times. And, the first, high pressure storage. High pressure storage solutions, they generate at a rate less than the actual peak demand, but they supplement those needs with stored nitrogen. So these are typically suited for lower volume users, and the big key point there is back to the hours of operation is running up to 12 or 14 hours per day. And the reason that we do that is because the downtime at night, coupled with some downtime during the day and whatnot, is when we're going to top up those storage vessels. So that every morning you're going to come into a full complement of nitrogen that can be supplemented during the day. These, like I said, they're made up of smaller components. That reduces the capital cost of the system. So that's why you would select this type of design philosophy. Now, in terms of sizing, in this case, we talked about peak hourly. In this case, it would be the peak daily usage because you are going to start with a volume. And, as long as we have a good understanding of what your heaviest day of use is, we designed around that. The other design philosophy is what we call mid-pressure on-demand solutions. Now, these are based on that peak hourly demand of your operation. So whenever you need that peak flow, the system is capable of generating it. Comparing these two to something in everybody's home, water heater, you either have your tank water heater or your tankless. This is the tankless version. Now, contrasting the higher pressure storage solution, often more suitable for higher volume users. And these are what you have to have if you are running in the 16 plus hours per day operation. But having said that, these are also still good for smaller users as well. So that's the design technologies and philosophies. Now, future proofing, talking about proper planning for the present and the future. Understand how you plan to grow your business. There's several different ways that you can increase production. Nitrogen generation system that you select or you employ should suit that. Talking about, adding equipment or lasers. So if you're only running eight to 16 hours a day, then this growth strategy really does suit the high pressure systems best. If you got a high pressure storage system, you can just add more storage and have more in supplemental supply. It's going to still take advantage of the downtime and utilize the lower than peak days, the evenings, and the weekends. And you can just continue to add how much it starts with, say, on a Monday morning. Again, these are all modular. It's all that we offer. So we can add on to it at a later date as well. Excuse me. Another, growth strategy is to upgrade to higher powered lasers. Same approach as adding lasers, but the increase of nitrogen typically isn't quite as drastic. Now, adding hours. If you have your generator or your lasers running 8 hours a day, take them up to 16, take them up to 24. Using an on-demand solution means it's on demand. So there's no need to increase any system design. The generator just simply runs more. The components, and all of our systems at least, are rated for 100% duty cycle. So they can run nonstop 24/7. So talking growth strategy, this is adding hours to your operation is suited to the on-demand solution. Now, if you don't know your future plans, either solution's expandable, so you're still covered that way. But if you do know or have a good sense of what your future plans are, there are ways to accommodate growth as well with an initial system design. You design it part way there. You can add on to it, maintain the ideal base design for the future state. And while you're future proofing, you actually likely end up providing yourself with some bonus redundancy. And that can be accomplished by reducing individual component sizes, increasing the number of them, ultimately, providing 50% or more redundancy on all or some of those components. And that can help you with preventative maintenance time and that sort of thing. So what this looks like, and as an example, a real life example on screen here, we provided this customer a system capable of what their initial current daily today needs are. And once their future state was realized, they added the lasers. We plopped in another compressor and another nitrogen generator. So we not only gave them that redundancy, we increased their system size. So now, as a side note, those high pressure storage systems, they do have some inherent redundancy built right in because you come in the morning and their storage is full. That generation system doesn't have to run it. You can still have, 75 or 21,000 cubic feet in reserve. Now, most metal fab shops that I've been into, they like to use their space for production. And given the sheer size of what you need for material handling and storage, how do you optimize your solution for your space? The first one, there's a few, but the first one is, standard installation. Of course, it's the easiest. And if you've got the space, the best choice. The most simple installation, laid out based on best practices by our engineering team and simplicity, while still making the best use of your space. Another, we can incorporate a mezzanine. So we often see these mezzanines used in laser cutting operations. They're holding the power supplies of the lasers. This frees up valuable floor space, makes use of, the dead space that's up there, and you don't have to pay property taxes on. It allows for production areas to remain as production areas, and building a mezzanine is probably something that you guys know somebody that can do, namely yourselves. Alternatively, you can keep your system outside. Now, having said that, the components do need to be protected from the elements in a climate-controlled environment, which kind of dictated between 40 and 100 degrees Fahrenheit, adequate air exchanges, space inside to do maintenance activities, etc. You can incorporate an enclosure and place this unit outside, but the engineering has to take into account climate control factors. You look at this example on screen, it looks like it maybe was a sea can one day, and it was, but a lot of customization happens to these in order to make them suitable. Like I said, heating in the winter, cooling for the summer, adequate air intake, ideally thermostatically controlled, adequate hot air exhaust, because these compressors do generate quite a bit of heat, and of course, insulation. Now, an enclosure, what that means, the system becomes turnkey. You just drop it in place, connect the power and the nitrogen outlet. Like I said, they got to be properly engineered for the application, and they do start, in many cases, start their life as a C can, but they're a whole lot more than that by the time that they're actually suitable to become a nitrogen generation outbuilding. Really good alternative. We're seeing a significant growth in the number of turnkey systems that we're putting in the field at an exponential rate, I would say. Now, what many of you wanted to come here probably primarily for is to talk about the cost, and we talk about the price versus value equation. And so, what are the operating costs? Now, operating costs include two inputs, and that's electricity and maintenance, and that's it. Now, to use the example from one of the case studies that I highlighted earlier, this particular customer, small user, was running 7,700 CCF per year in nitrogen. Like I said, smaller user, but these cases, they scale pretty linearly. Their operating costs to generate the nitrogen that they were using in a year was $1,300 in electricity and $10,000 a year in maintenance. That's it, and that's all the input costs. So nitrogen was costing them $65,000 a year to buy. We reduced it to about 11,000. Again, I think I've said it 3 times because it's very important. There are no other operational costs. When we provide through our free assessment and our ROI payback and feasibility study that we provide to our customers, we're going to state the amount when we provide the cost to generate. We're going to actually state the total amount of electricity and maintenance per unit of nitrogen. This is not a number that's in addition to the maintenance and electricity. Consider that all in. So in this case, their cost to buy nitrogen was $8.42 per CCF, $1.47 to make it, so an 82% savings. Talked about operational costs. Now onto the capital. Capital cost is of course important, but how the capital costs can impact your cash flow should be of greater concern. So looking at it though, look at it as though you're moving where you spend your money and saving it while you're doing so. From that same case study, it played out that they were spending $65,000 a year. When they took into account, factored the capital cost by going on to on-site nitrogen generation, their total cost, excuse me, was 53,000, and that was during the finance term. So they actually financed it, and their finance payment, their electricity cost, and their maintenance was $53,000, and that's during the finance period. So instead of handing $65,000 over to one supplier, they saved over 12,000 by putting some to the power utility, some to the annual maintenance kitty, and some to the lender. And then after that finance term, their annual savings became $53,000. So effectively what you're doing here is you're making that payback period immediate. And that's due to the fact that month one is costing you less, including that capital repayment cost. In this case, they were saving $1,000 a month, so $1,000 more cash every month for the first 5 years, and then almost $4,500 a month after that. So makes incredible financial sense in either the capital purchase model, but also in the lease to own model as well. So it's good to know. So we've gone through quite a bit of information, as my throat is alluding to with the scratchiness, but to summarize what we went through and what you need to know, understanding the shift, understanding what the benefits of nitrogen generation are, those big now three, now four, the system options that you've got, technologies and philosophies, and then the true costs, optimizing for your space and the true costs. So with that, I want to thank everybody for their time. I really hope that you saw some value in this information. Additionally, I'd like to invite any and all attendees to reach out to us. We can provide you with that free assessment from one of our laser cutting nitrogen specialists. We will guide you through all the requirements we went through today and provide you with some high level insight as to what the value of on-site nitrogen generation is going to be to you, and with your specific needs in mind. So I know there's a lot of information. So as such, feel free to reach out to me directly at any point to discuss any of this in more detail. But with that, I'll hand it back to Victoria.
Amazing. We actually have some questions coming right in, which is amazing. First of all, thank you, Brett. The first one is how heavy a maintenance bill is there on these systems?
Yeah, maintenance. So maintenance is, as I mentioned, one of the two input costs. Now, the value of the maintenance or the dollar value of the maintenance on these systems is going to change based on, what the system components are, the size of it, so on and so forth. It's hard to pinpoint what that's going to be, but what I do want to say is that maintenance cost is part of that input cost. The maintenance and electricity, and in the last case, that the finance payment. So what we're going to be looking at is what does that, while the maintenance may seem as a standalone item, something that's heavy, when you take into account the fact that you've got the maintenance and the electricity all distilling down to something that's 80% less than what you're paying, that's where we want to put our focus, and where I can put the focus, at least in this sort of, what's the word, anecdotal or not anecdotal example scenario where I don't know exactly what size system your particular needs would be. So.
Perfect. Another question that came in was, where is the break even between these and cradles?
Okay, so cradles, by cradles, I'm assuming you mean bulk packs. Where is the break even? The break even, I can't pinpoint exactly where it is. Again, that's going to be done on a case by case basis based on how much you're using and what you're paying. But what I can say is it's lower than you think. The break even or payback period is lower than you might think, and that's because maybe you're not using a lot, but you're paying a lot for it. So you're going to have a high cost to procure your nitrogen, and a relative to a larger user, maybe a higher cost to generate, but it's still going to represent that 80% savings. We can tell a lot about how much you use by the method in which you're buying it. If you're buying bulk packs versus you're in a micro bulk, or you're in one of those big white tanks outside with the evaporator, um, the payback is typically in and around the same period, call it on average between 1 and 4 years. And that is the same whether you're in the bulk packs or in the big bulk tanks outside. And that's because in the bulk packs, you're buying a little and paying a lot. In the big bulk tanks, you're buying a lot and paying less. So it's still, where it breaks even is entirely dependent on your particular, scenario. Safe to say that, usually longer than a year, and 90% of the time under 3, 4 years.
And then we have one more, I think, that just came through. It's, do you rent systems?
We do not rent systems, and I'll explain the reason why first. We don't rent systems because these are all custom. These are all, purpose built for operation A versus B through, all the different permutations that exist. So for us to actually hold on to something that we can send out that is a one size fits all for everybody just doesn't exist. Now that's the reason we don't rent. But what I do want to do is, if I can put not a twist on that question, but just elaborate on it a little bit. Um, if it's a capital cost concern, let's go back to that finance or that lease to own option, because you can be cash flow positive with the use of on-site nitrogen generation from the first month that you use it, by employing that purchase strategy. It'll accomplish the same thing as a rental system. Um, from a financial standpoint, it's going to cost you less. But what we are often up against is, or not up against, but requested a lot of customers ask us for is they don't want to be in a rental situation. They want to have an asset when this is done. And going back to the finance or the lease to own strategy, you pay for it for 5 years. With proper maintenance, you can have it for over 20. So we don't rent systems, but we definitely work with people such as yourself that are looking for a lower or a less cash intensive opportunity or option for getting into new technology, specifically nitrogen generation.
Okay, perfect. I don't think if there's any more questions, please put them in the Q&A section now. But if that's all for today, I just want to say thank you again, everyone, for joining. We hope you found this very valuable. Brett will be following up with you along with this recording on behalf of the Purity Gas team. We look forward to connecting with you soon, and thank you.